You know that perfect shiny metallic finish on a plastic part? Or how about a super complex piece of machinery that has a protective coating in every last nook and cranny? Ever wonder how they do that? Well, today we are diving into the science that makes it all happen. And here's the twist. It's done without any electricity at all.
I know, it sounds a little bit like magic, doesn't it? We're so used to thinking that plating needs a big electrical current. But what if I told you that you could get a flawless, mirror-like metal finish using just some really clever chemistry? That's the big question, and the answer is changing the way we make everything from our phones to life-saving medical gear. And that answer is called electroless plating. Basically, instead of using electricity to force metal atoms onto a surface, this process gently coaxes them into place. It all happens through a controlled, self-powering chemical reaction. The result? An incredibly precise and even layer of metal, even on the most ridiculously complex shapes you can imagine.
All right, so here's our game plan for this explainer. First, we're going to look at the perfect chemical recipe that makes this all work. Then, we'll get real about the biggest plating hurdles, the challenges scientists are up against. And finally, we'll get a peek at the future of surfaces and where this is all headed.
Okay, so let's start with the heart of the whole process, the plating bath. You really should think of it as a kind of high-stakes chemical soup. Getting this recipe exactly right isn't just a suggestion, it's everything. If even one little thing is off, the whole batch can be ruined. To get it right, chemists have to become master chefs, balancing 4 key things at once. First, you've got the bath composition. That's your main ingredients. Then there's temperature, which is like the heat on the stove, driving the reaction. You've also got the pH level, which sets the whole chemical mood. And finally, my favorite part, the additives. These are like the secret spices that can totally transform the final dish.
And when I say balance, I mean it's an incredibly delicate act. For instance, the exact ratio of the metal you're plating to the chemical that kicks off the reaction, that's the molar ratio, has a huge impact. Tweak it one way, you get a super hard surface. Tweak it another, you get a faster process. The real trick is finding that perfect sweet spot where you get both. Temperature is basically the gas pedal for this whole reaction. For a lot of the most common recipes, 90 degrees Celsius is the magic number. It's hot enough to get things moving at a nice, steady pace. But you have to be careful. If you go too cold, the reaction just crawls along. And if you go too hot, the whole bath can go haywire and start plating metal everywhere, not just on your part. Now check out the power of those secret spices, the additives. On the left, you've got a standard silver coating. See how the grains are kind of big and clunky? That makes it weak. But on the right, whoa! Just by adding a tiny pinch of something called cerium nitrate, the grain size gets way smaller. That makes the coating denser, tougher, and much better at resisting corrosion. It is a night and day difference.
And it's not just chemistry we can use physics too. By blasting the bath with ultrasonic waves, we can literally shake out the tiny imperfections as the coating forms. Just look at this chart. With ultrasound, the porosity, the number of tiny holes in the coating, plummets to almost zero. And a less porous coating is a much stronger coating. But even with all these tricks, it's a constant challenge, which brings us to our next part.
So, as powerful as this all sounds, it is far from easy. Getting a truly perfect coating is this constant battle against the laws of physics and chemistry. These are the hurdles that scientists and engineers are wrestling with every single day in the lab. What are they up against? Well, there are 3 big ones. First, you need the thickness to be perfectly even everywhere, which is a nightmare on complicated shapes. Second, the coating has to stick, and I mean really stick. Any tiny bit of contamination, and it could just peel right off. And finally, you're chasing zero defects, but these tiny little enemies, like pores and microvoids, are always trying to sneak their way in. And this isn't some abstract problem. Take a look at this quote from a recent paper on making electronics. A blind via hole is just a fancy name for a microscopic tunnel inside a circuit board. Trying to get a perfect coating inside one of those things is, as they say, challenging. But we have to figure it out, because the phone in your pocket relies on it. On top of all that, if your control slips for even a second, the metal atoms can start building the wrong thing. You can get these awful, sharp, needle-like crystals growing on your surface, and instead of a smooth, protective shield, you end up with a brittle, useless layer that just shatters. It just goes to show you, control at the microscopic level is everything. But of course, for every single challenge, there are brilliant people working on an innovation. So now, let's look ahead. Let's see how science is breaking down these barriers and turning electroless plating into a technology that's smarter, greener, and more powerful than ever before.
This future is really standing on three big pillars. First up, we're making it greener. That means getting rid of nasty, hazardous chemicals and finding safer alternatives. Second, we're making it smarter. Think real-time sensors and AI that monitor the bath and make tiny adjustments on the fly to keep everything perfect. And third, we're making it circular, figuring out how to pull valuable metals out of used solutions so we can use them again.
And all these advances are unlocking some incredible new applications. We're talking next-generation electronics for sure, but also advanced energy systems, like tiny beta-voltaic batteries that can last for decades. And it's huge in medicine, for coating surgical tools and implants where perfection is literally a matter of life and death.
But honestly, this might be the coolest part. It's called composite coatings, and it is straight out of science fiction. Scientists are now mixing nanoparticles right into the metal as it plates. Imagine adding PTFE, that's the non-stick stuff, to make a self-lubricating gear, or embedding nanodiamonds to make an ultra-hard surface. We are literally building materials that have superpowers baked right in. And that really brings us to the biggest question of all. This technology gives us the power to design and build surfaces, literally atom by atom. We can control matter in ways we never could before. So as we get better and better at this, the only real limit is our own imagination. What will we build next?